So all too soon we have ended the second week and we are in the third week. And last week we did a lot of interesting things. Variables. We did a lot of interesting things with data types. And we also did a lot of interesting things. Um, this week is going to be different. We are going to continue with uh, some of the knowledge we picked up last week, which was the second week. So in the third week, we are going to look at what we call data structures. Data structures. And it's important to make mention of data structures because I introduced last week, I introduced what data is. And I said that data are values that run as our program runs. So they are sometimes held in variables or they can exist within the program entered manually. And we said that some of the sources of our data can be databases, can be users, can be directly inputted by the programmers. So with this data existing, we need to understand the data we are working with and what are its limitations, how we can identify them, work with them. Um, so we'll look at vectors as a data structure, we'll look at matrices as a data, we'll look at arrays, and we'll look at data frames and lists. It's important to take a look at these very common forms of data structures. And then if we have the opportunity, we'll look at indexing. So week 3 is dedicated to this. Um, let's talk about data structures first before we deal with indexing. So I'll give you a brief introduction on data structures. What vectors are, what matrices are, what arrays are, data frames are, lists. These may seem new words to some of you, and for people who have maybe done some maths, they may see vectors as a common thing. They may see matrices. Arrays are for people who perhaps have some prior experience with some other programming languages, which are found in there. Some languages even call them collections. And data frames, if you've done any form of analysis, then you might come across it because when you import a file, you import it into a data frame. So more like a spreadsheet. Let's talk about them finally. So the structure of the data helps you understand what you can do with that data and what you cannot do with that data. Okay. We say that a vector is a one-dimensional array. One-dimensional array, um, and it has to have the same data type. Okay. So I spoke with you last week about what data type is. And we said we have various forms of data type. We have the numeric data type. We have the character data type. We have the logical data type. And we have the complex data type. So if you pick a vector, they have to be the same data type. Okay. So if let's say you have a vector called Nana, and usually this is how we write a vector. C first, we concatenate, then you start putting your elements of the vector in there. So if let's say this vector is made from logical, the data type is logical. Last time I said 2, T can represent that, F can represent false, F again can represent it. This vector, Nana, is a vector that's made of Boolean. So we've created a vector. When we come here, you see it's a logical vector. It's a logical vector. If we want to really understand what type of vectors it is, we can still say type of Nana, and that gives us logical, meaning that it's made of Boolean values. It's either a true or false vector. They have to be of the same data type. That's for vectors. Okay. So let's take that in mind. They have to be of the same data type. And we write them. So anytime you are writing and then you see a C and brackets open, bracket close, and you have a list of elements in there, check it out. So let's say if I write Nana, and let's look at this interesting. Let's say now I want to set Nana to a different vector. Let's say here I write 1, then here I write a character, which is, let's say, AB, and here I write 5. So I have 3 elements here, 1, AB, and 5. 1 is a double, 5 is a double. This is a character or a string. AB is a string or a character. However, what happens is because of the existing character, when it asks for its conversion, it will convert all of these things to characters. So let's take a look. When I say Nana, so you see 1 is in a string, AB is in a string, 5 2 is in a string, meaning that it has converted all of them to characters, even though this is a double. 1 is a double, 5 is a double. If I say, okay, well, what is the type of data for Nana? It says character. Okay. So they all have to be of the same data type. So usually the prevailing one will override the other ones. That's what happens with vectors. Okay. It's important to understand that it's a one-dimensional array. When we say a one-dimensional array, it means that it has only maybe rows. It doesn't have columns. Okay. That moves us to the conversation of matrices. Matrices are two-dimensional data or two-dimensional array, and they have rows and columns. That's what makes them two-dimensional, rows and columns. And columns have the same length and class. When we say class, the same data type, okay, or the same classification, okay. So they have the same length. The column have the same length and class. So let's say if I write a matrix, if I have a matrix running, let's say I say that I want to create a matrix. This I want to turn this into a matrix. So I say matrix, create a matrix for me. The function matrix is used to create a matrix. And this is how we write a function. You write the name of the function, which is matrix. Then you open a parenthesis and you close the parenthesis, brackets, and close the bracket. Then you enter what we call an argument. An argument is what the value the function should act on, okay, or the value the function should act on. So later on we'll do function, but I needed you to understand that, for example, type of is a function. So if you see something like this, type of, and it's acting on this, it's in a bracket. Type of is a function that tells or returns the type of data you are dealing with. Over here, Q open close is a function, close bracket is a function that's kind of, let's say, quits your program. Okay, so we are going to use the matrix function. And with the matrix function, I say, okay, well, I have numbers listed 1 to 6. That's what I want my matrix to be of. So first, it will ask me for my data, the data I'm going to supply. I say the data should be this. The number of rows should be 2. And my matrix is ready. Okay, so I have 1, 2, 3, 4, one column 6 means that a range of numbers from 1 to 6. So instead of me writing 1, comma 2, 3, 4, all the way to 6, I said one range of numbers 1 to 6. And in defining a matrix, you have you have um, let's say it's by default arranges by column. Okay, so by default it arranges by column. So you have 1, 2, 3, 4, 5, 6. So this is an example of a matrix. And when we come here, we say that matrices are two-dimensional data, okay? Rows and columns. So let me show you where the rows are. These are the rows. This is the first row. That is the second row of data. So row 1 is seen here. Row 2 is seen here. These are the columns. The 5 and 6 are in one column, column 3. Column 2 contains 3 and 4. Column 1 contains 1 and 2. Row 1 contains 1, 3, and 5. Row 2 contains 2, 4, and 6. So that's about columns and rows. So when we say matrices are two-dimensional data, we have rows and columns. Columns have the same length and class. Okay, the columns have the same length and class. Let's look at what the columns are. These are the columns. They need to have the same length. You can't have one of them being longer than the other. Okay, so you can't have 1, 3, and maybe 16 in column 1, and you have only 3 and 4 here. So they have to be of the same length. The columns have to be of the same data type or class. So it means that I can't have A here and I have, what do I say, 2 here. Okay, and I can't have B here and I have 3. When I do that, what's going to happen is it's going to override all of them into columns. So let's do an example here. Okay. So I want to have a situation like that where I have 1 and I have A and I have, let's say, 2 and I have B and I have 3 and I have C. Yeah. So this kind of matrix, so you see, even though one here is a number, it's overrode or it's a double, the character overrode it and made all of them characters because the columns have to have the same data type. Okay. But initially, so when I come to Nana and I say maybe type of Nana, it will say character. Okay. So Nana is a character here. All of them is assumed to have the same. So when you write one double and you write one, let's say character, what's going to happen is it's going to be overridden and then it's going to choose the prevailing one. But initially with the initially with this kind of data matrix we had, if I say type of Nana, you see it's an integer. Okay, so all of them are integers. When you use a column, it writes integers out for you. But if I manually write them out, then it will write them as double for me. So that's one thing about matrices. They say there are two dimensions of data. We have columns, and the columns length and class have to be the same. The columns are not named and they are referred by their index numbers. Okay, so these are the index numbers. Okay, one, column one, two, we have column two, three, containing three and four. Three, these are the index numbers. The rows and the columns have index numbers. Okay, they are not named. It's important because we'll get to a point where other columns are named. That's why it wants to specify. And it says an array is a matrix with three or more dimensions. And we'll do an example of an array for you to see what. So an array has more dimensions. Then we look at a data frame. Okay. A data frame can have vectors of multiple types. This is the vector one dimension array. Can have vectors of multiple types, but they have to have the same length. Okay. They have to have this. When we say the length of a vector, a vector is a one-dimensional. So like the initial Nana I wrote, like this one, is one-dimensional. It doesn't have rows and columns. It has only, let's say, a row. So when I come in and request for Nana, true, false, true, it has only one row. It's one-dimensional. But it says that over here, it's telling us that if we are dealing with a data frame, you can have several of these vectors. So I can have Nana, I can have maybe Yao, I can have other vectors, but they have to have the same length. When we talk about the length, it talks about the number of elements that are in there. So if I have three elements in here, then it means that the other vectors to need to have the same length. They need to have the same number of elements in there. Okay. That's what we mean by that. And the data structure is very close to that of a spreadsheet. We'll come and understand why we are saying that. And lists are an ordered collection of elements of any class and any structure. So it means that with a list, you can have elements that are mixed up, but with a vector, they have to be of the same class, or the data type have to be the same. Lists can include lists, and we'll get to that. Why we say you can have a list inside another list. So let's look at vectors. An example of how to create a vector. We've done a scenario for explanation purposes. We say a vector is a one-dimension array consisting of the same data type. That's very important. They have to have the same data type. When you write this and you expect that, okay, it will be mixed up. No, because it's a vector, what's going to happen is the character will override the numbers because it's prevailing. So all of them will be character. So when we come here and say v1, creating a vector v1, I want us to take a look at something. Creating a vector v1. So let's look at, this is a vector v1. Okay, so our vector is created. And we have a number up here. When we come to type of, we want to see the type of this v1. It returns a double. This is 1, 2, 3, 4, 5. It's all considered as double elements. Okay, they are all considered as double elements. However, it's interesting because if I write out, let's say v2, and say v2 contains range of numbers from 1 to 5, range of numbers from 1 to 5, they are going to return an integer set. So if I type out v2, let's look at v2. You see v2 is like 1, 2, 3, 4, 5. And let's look at v1. v1, 2 is like 1, 2, 3, 4, 5. Look, there's no actual difference in between them. But we check for the data type of v1. Let's check for the data type of v2. That's where the surprise is. So the V1 is giving us uh, a double over here, even though it contains the same elements. The numbers in there are double. Okay. And these ones are integers. Integers. Even though, so whenever you make a range, whenever you set a number according to a range, what's going to happen is the numbers which are going to populate as elements of the vector are going to be integers. So when you set a number to a range, what happens is the numbers it populates them with are integers. It's worth taking note of because if this doesn't happen, you won't, but if you set the numbers yourself manually, it will set them as double. Okay. To set them as double. So it's worth taking. I wanted us to just take note of it, that because we set this 1, 2, 3, 4, 5 by ourselves, the type became double. Okay. And if we have to use a range of it, then it becomes integer. So this is an example. And with this V2, we did a similar example. So we have, that's why we have this data type as double, okay, over here. That's why we have it as double. But over here, we have it as character, even though we see 1 and 3 in there. And I previously explained why that happens because this kind of overrides the so now V2 has been overridden. When we check the value of V2, see all of them are in quotation. And when we check the type, it returns a character. So it's very important that even though we see numbers there, we shouldn't be deceived that for vectors, they all have to be of the same data type or class. Okay. So let's take that note. It's very important. And this is for checking if something is a vector or not. Okay. So if let's say I go here, I come here after I've created the vectors and say, I have some variables here. I have Nana, I have num, I have this. All of these things are vectors. So I can come here and then ask, is vector, this function vector, so then I push in my data object. So when it returns true, that means that Nana is a vector. If it returns false, let's say if I have another variable in here and say that, let's say it's called V3, and V3 is not a vector, it's set to 34. And I come here and I ask, is vector V3, is vector V3, then it's going to say true instead of the other thing. Okay. So these are ways we can check for a vector. If it says false, then it means that that thing is not a vector. Okay. And the basic data type is vectors. The basic, I'll say, data structure you have is vectors. That's the basic. Okay. So let's always have that in mind. Let's always have that in mind. All right. So this is for checking if something is a vector and it returns a logical. A logical, we say a logical or Boolean. They are the same thing. And matrices. Let's look at matrices. Now we said matrices are made of 2 dimensions. Okay, they have rows and they have columns. With the columns having the same length and class. The columns are not named. They are referred to by their indexes. The indexes are what we spoke about. So this is kind of creating an example of a matrix, which is similar to what we did. And we said that by default, this matrix will populate in terms of columns. It will fill the first column first. So let's say V1. Let's run V1 and then see what uh, this matrix becomes. M1 is our new matrix. And so when I want to check what M1 is, I just type M1. And then it beats me. So I have 1, 2, 3, 4, 5, 6. Because I listed them out myself, when I ask for the type of matrix, the type of data, it should say, uh, let's say double, okay? It should say double. But if I use a range like 1 to 6, E1 to 6, um, so let's say I defined M1 saying, well, give me the range of numbers from 1 to 6. And I check for the type of M1 now. M1 should be an integer. Okay, type of, it should be an integer. So it's worth taking note of. And we said that, look, 1, 2, 3, 4, 5. It populates according to columns. So 1, 2, 3, 4. The next column, 5, 6. So it populates according to columns. If you don't want that to happen, then you need to introduce a third variable in the function called by row, and you set by row to true. So it means that arrange it by row this time. Set it to true. When that is set to true, then it means that your your elements will be arranged by row instead of by columns, which is the default. So let's take a look at that and say we've created this time we added a new argument called by row. And the by row ensures that the data we are setting is arranged by rows. So let's look at what M1 is now. So the elements were arranged by 1, 2, 3, 4, 5, 6. Okay. It's always important that you have that in mind. By default, it arranges by column. And if you don't want that to happen, then you have to set by row to T, which is true. Okay. So that's basic about forming, and we use the matrix function. Okay. So, and in R, if you want to know more about a function, all you have to do is you bring a question mark and then you mention the name of the function, like matrix, like this. So you see, it brings me matrix creates the matrix from a given set of values. It gives me information on it and how the function can be used, the data, the number of rows, the column, the by row we spoke about. By default, it's set to false. If you want it to be true, you have to set and the thing name. So you can learn a lot about functions just using this. First bring question mark, and then you can ask it an array, and voila, it should bring you information on arrays. Okay. Then so it's like a notebook where you can always have your information there. And so let's look more on matrices. So this is an example of matrix. Creating a matrix from a vector. Okay. Creating a matrix from a vector. So let's say you have some 3 vectors. V logical, have V numerical, which is another vector, 4, 5, 6. This 4, 5, 6, what data type do you think is going to be? Is it going to be an integer or is it going to be a double? It's going to be a double. Okay, it's going to be a double. If we set a ring that 4, column 6, then it's going to be an integer. Okay, and the character is ABC. Okay, so this one we should have put them in quotations. So let's say Okay. In vectors, if you are certain, you can separate them by semicolon. Semicolon says that end, I'm done with this. Go to the next line, I'm done with that. So A here, B here, and C here. So even though this looks like T, F, T, note that uh, it's not a character or it's not a string. Okay, it's not a string. It's a Boolean or a logical. Okay, so we have three logicals. Okay, we've entered, means we've created the logical here. We've created this. These are three vectors. Okay, the logical, the numerical, and the character. Now we are going to demonstrate how to use cbind. Cbind is a function for binding vectors. So it's very simple. The cbind here, all you have to do is separate the vectors you want it to combine. And it will do that and combine. And at the end of the day, the prevailing data type is going to prevail against all of them. So let's use cbind and then let's use that example and see. Okay, so cbind as a function. We want to create a new matrix called mat. And we say it should be formed from cbind and v logical, v numerical, and it should be formed from v character as well. All right. So now we have a new matrix here. Matrix, MAT, it's here, it's here. So when I come MAT, it's just picking up something I don't want. Okay, so let me just change this name to M2. Okay, so that when I type M2, I don't have this popping up. So the value of M2 here is, you see, I told you it will arrange it by, let's say, column. So the first one populated the first column, the second one populated the next column. But look at this, it has names at the top. It has names at the top. So that's an example of how we have this function here. The resulting matrix will be a character because it's the most general. That's what I spoke about the last time. So let's look at an array. What an array is. Okay, an array is a matrix with three or more dimensions. So we have a matrix that has three or more dimensions considered as an array. And that's how we create an array. Okay. Use we use the function array. The function array. But I told you how to use a function array. If you want to write a function, it's like you write the name of the function, then you bring the brackets. Then you supply it the data or the arguments the function is supposed to use. Okay. So there's an example of an array that is created already. A1, And after we do this, it has created an array. Remember, we used the array function, this function, okay? And we say that, okay, well, the range of values should be 1 to 24. Okay? And let's see how A1 is showed. Okay, so that's two matrices. It has two dimensions. Okay, it has two dimensions. Um, each matrix is a 3 by 4 dimension, anything two. So it's it's more like a multi-dimensional matrix. Okay, that's what we term as an array. And a data frame, a data frame. So we said that a data frame can have vectors of multiple types, but they have to have the same length. Okay, similar to a spreadsheet. It's very similar to a spreadsheet, and it has special function. So to create a data frame, you can use as a data frame and cbind. You combine the two. So we saw cbind earlier, how we used to combine these data using cbind. Okay. So that happens. What do you think is happening here? We are creating a vector, a matrix from 3 vectors, okay, using cbind. And that vector is called, that matrix is called DFA. When we finish, then we use as data frame to convert the matrix into a data frame. As data frame is also more like a function that handles that. Okay. I told you about coercing the last time. Coercing is your ability to change from one data type to the other, from an integer to maybe a double, or from a string to something else, from a boolean to a string. You can do that. And as data type helps you, as data frame helps you to change from maybe a matrix to data type, to data frame. Okay, so this is how you do it. So basically, it's initially we've done this. We had 3 numerical, and then we created a matrix called M1 out of that. Okay, so let's look at how we form the data frame from that. So we had M2. M2 already exists for us. M2. Remember, M2 was created from the V logical. The V is a this thing that we created from that using the cbind. Now we want to say that our data frame should be df. The variable df should be as data frame function, and then we give it this value, which is M2, the M2 we had. So it converts this particular matrix into a data frame such that when we say df, we have a data frame. So remember, so look at this. This one was showing us like in columns, the indexes, but this one is more like a table. Okay, 1, 2, 3. So it's a data frame. Okay, this one looks more like a spreadsheet. Okay, so you can have true, false in here. You can have 4, 5, 6. It doesn't have to mix up. Okay, data frames can contain several types of data within columns. Okay, so that is one thing worth knowing for data frame. For Excel, for matrices, they have to contain the same. Each column has to contain the same kind of data type. Okay, so that is one thing with data frame. And the final one is the list. The list is an ordered collection of elements of any class or any structure. Okay, any class or any structure. So you can have this. It's a list. That is a list. That is also a list. Okay. And you can have a list inside a list, and that's what it's trying to. So this is a list. O2 is a list. O3 is a list, but we are using the list function to create another list out of them. So let's quickly go with this. Okay. Yeah. Sorry. The the So if we were to create, let's say, different lists, they can be of different dimensions. Okay, one can be longer than the other. We don't really mind. So okay, why I say D is not found is I didn't put it in a quotation. Okay, so we have O1 defined, we have O2 defined, we have O3 defined. Now I can use the list function and say new list. My new list is a variable that I'm creating to hold a new list that I'm creating. So the list function is written this way, list, then you bring your brackets. Then I can say O1, which is a vector, should be a list inside my list. Okay, so 0, 1, O2 should also be in there. And O3 should also be in there. Okay, so I have a new list now. When I type new list, I want to see the content. So I have a list inside another list. Okay. So this is a list, that's a list, that's a list. But O1 is now inside the new list. Okay. O2 is also a list inside new list. O3 is also a list inside new list. Okay, so that's a demo of how you can have a list inside another list. And so with that said, now let's look at how we can verify a data structure. Okay, we've written several data structures. We want to see if this one is it a vector or it's not a vector. We use the is, then dot, the data type that you want to check for. So if you want to check for an array, you want to say is array, then you bring your data object here or your variable here. Okay. And what it returns, it will either return a logical, it will return a logical, either true or false. If it returns a true, then it means that indeed it's the data type you used here. But if it returns a false, then it means it's not the data type you specified here. So let's do an example in our studio. Let's say right now I want to check is df a vector. So I'll say is vector df. It says false. False means that it's not a vector. But when I ask this is data frame df, it will say true because df here is a data frame. If I want to check is df a matrix, I'll say is matrix df, and it will say false. df is not a matrix because look, with the matrix we formed, which we used to was M2 here. So we use the value of M2 here. M2 is the matrix here. That's what we use. We converted M2 here as a data frame. So now DF's value is a data frame. M2 is a matrix. Okay. So, but if I ask it, is matrix M2, it will say true, matrix. So that's a way you can confirm the data type if you are not too sure about it. And you can use the is and then followed by your data structure. Then you enter your data object in brackets. And that's how we confirm. So these are examples you are seeing. This like a vector, that's a matrix, that's an array. And after it's all done, it's asking, it's kind of querying. So is V1 a matrix? Okay, is it a matrix? No. So it will return a false since V1 is not a matrix. V1 is a vector. Is M1 a matrix? Yes, because it was formed using the matrix function. So it will return true. Okay. So it's worth noting that these things exist. And that's how we end data structures. Remember that it's key to understand the limits within which you work. So a recap is like, so for vectors, we said they are one-dimensional array. They have the same data type, and it's R's basic data type. For matrices, they are two-dimensional. The columns have to have the same length and class. By class, we mean classification, or it also means the data type. Okay. The columns are not named, okay, but when you come to data frame, you see that the columns are named. Okay. So let's go to our studio and then see. This is an example of a data frame. The columns are named DF. So you have they have names. But when you come to matrices, the columns are not named. Okay. The columns are not named. All right. They are referred to by indexes. An array is a matrix with 3 or more dimensions. So you can have that. And a data frame, I said, they can have vectors of multiple types, but they must have the same length. Okay. The length is like the number of elements in the vector. Okay. And the data structure is closest to a spreadsheet. So as you saw the DF, it looked more like a table. Yeah, and you can have thousands rows and 1,000 columns in a data frame. Usually when you import something from Excel and you want to work with it in your statistical analysis, we import it into a data frame. So it looks like a table. Okay. And the list here is an ordered collection of elements of any class of structure. And a list can include splits. That's what sometimes we term as nested lists. Yeah. With this, we come to the end of data structures. I hope you enjoyed data structures. And it's crucial to understand some of these things because while working in operations, sometimes if you don't get these things right, it affects you because you might be mishandling certain data. So maybe the thing is, it's a vector and you think it's a matrix, or it's a matrix and you think it's a data frame. There's always a way to confirm. However, if you know it offhand, that helps you. Okay. So with this, we'll come to the end of the class for data structures. I'll see you in the next class.